Production management involves monitoring components of the production system. Choosing the example of oil production, let's say that I want to monitor the health and status of compressors used to push the oil into pipelines. First, I use the Treemap to get an overview of my equipment. The whole display area represents my region of responsibility. There are 3 areas, so the screen is split in 3. And then split again to show the exploitation fields in each area. And finally, I can see the individual compressors for each field. The red color shows a number of warnings in the last month for each compressor. As you can see, the slice and dice algorithm generates very skinny rectangles. To avoid this problem, we use a squarified algorithm that packs the item while favoring low aspect ratio. To see the current status of those compressors, I choose to color each compressor by the severity of the currently reported problems. I can see that some compressors are doing just fine, while some others that appear very red are having several problems. Okay. Next, I set the size of each compressor to be proportional to the flow of oil compressed in a day. I can now see that some compressors are more critical than others to the overall production. Clicking on the compressor brings descriptive information in the detail window. We can also filter the display using dynamic query sliders. For example, I can decide to ignore the compressors that have had no or few problems in the past months. They are grayed out as I move the slider, or I can hide them completely to reclaim the screen space. When I have identified the compressors I need to focus on, I want to look at a table showing the history of the problems. This Fisheye table shows the values of 89 parameters of the selected compressor. We see the values for today, the past few days, and the average of the last 15 days and the last 45 days. The Fisheye effect allows me to choose a subset of parameters to be seen in details. The length of the bar is proportional to the value of the parameter. Green means that the value is in the normal range, orange is borderline, and red is abnormal. For this compressor, you can see that many parameters are abnormal and have been for a while. In comparison, this view of a different compressor shows that its health is much better. Most values are normal. Only one parameter is in the red, and I could see also that it was also in the red in the previous 45 days. The smooth fisheye effect is helpful to search for a specific parameter by browsing the list of names. Notice how we can lock the focus area by moving the mouse to the darker gray region where the cursor can move without changing the focus. The fisheye effect allows rapid focusing on a group of neighboring parameters, either by sliding the focus area on the left column or by clicking on an area of interest to move the focus area automatically. Of course, this is useful only if the neighboring parameters enlarged together are related to each other. Alternative layouts are possible. Here we flip the table so that time goes this way from today to the previous month. This makes it easier to compare the length of the bar over time and also to focus on a specific time period. The problem is that now the 89 parameters named do not fit horizontally, so we had to aggregate them in groups. For example, this column summarizes all the gas flow parameters. Bringing the cursor on today's red bar tells me that only one of the parameters is abnormal. Or I can click on the column and open the history of the parameter group. The challenge here is that the grouping of the parameters has to be formalized. We believe that the Treemaps and Fisheye table browsers provide powerful overviews of production data. Treemaps can help you see items in need of attention, while Fisheye table browsers provide an interactive overview of parameter history.